Hello and welcome back. In this video, we're going to be continuing our practice with subtracting fractions with different denominators, but we're going to kick it up a notch even more this time. Let's just jump in with the first problem. 1 1/3 minus 3/4. Our first step is to see that we have two different denominators, but more importantly, if we try to just bring the 1 over and then subtract the fractions, 1/3 is less than 3/4, so we can't subtract that fraction unless we convert the 1 into an improper fraction over here, so that we can take full advantage of the whole number, because 1/3 is not enough to subtract from 3/4. So let's try that. Let's convert 1 1/3 to an improper fraction. With a base of 3, 1 1/3 becomes 4/3. And so now we have this problem. Still, this problem we can't do because of the different denominators. So let's write out the multiples so we can find the least common multiple of 3 and 4. 3, 6, 9, 12. 4, 8, 12. So we're going to be using 12. 3 times 4 is equal to 12, so 4 times 4 is 16, minus 12. 4 times 3 is equal to 12, so 3 times 3 is equal to 9. Now we have 16 minus 9 is equal to 7 over 12, and that's our answer. So this is the first method you can use, turning the first fraction into an improper fraction and then solving from there, so that just in case the smaller fraction is not enough for you to subtract from. Okay, now let's look at the next problem. 3 1/2 minus 1 1/3. In this case, you can see that 1/2 is bigger than 1/3, so we should be fine just subtracting and not borrowing from any of the whole numbers. But first, let's convert each fraction to its another fraction with a different denominator. So 2, 4, 6, 3, 6. So 6 will be the first one. That will be the new denominator. 3 with a denominator of 6, 1 with a denominator of 6. 2 times 3 equals 6, so 1 times 3 is equal to 3. 3 times 2 is equal to 6, so 1 times 2 is equal to 2. This is our new problem. We just rewrote the fractions. So 3 minus 1 is equal to 2. 3 minus 2 is equal to 1 over 6. Our answer is 2 1/6. Now let's look at our next problem. 3 1/2 minus 1 2/3. You can see that 1/2 is less than 2/3, so we're not going to be able to subtract 1/2 minus 2/3. So we have to transform this first fraction in some way so that we can be able to subtract the fraction. You could always just convert the entire thing to an improper fraction like we did in the first problem, but we don't have to do that, because what will happen is we'll end up with extra, and then you'll have to reconvert it back into a mixed fraction. Something easier that we can do that's more concise is basically borrow 1 from this whole number. So let's say we borrow 1, and then this becomes 2. The one whole number that we borrow will be added to the fraction. So if we were to add 1 to this fraction and continue to have it be an improper fraction, the numerator would become 3, because 1 in fraction form is 2 over 2. So we do like 1/2 plus 2 over 2, which is 3 over 2. So now we have this new problem that's 2 3/2 minus 1 2/3. So let's then convert this new problem into the fractions with the same denominator. So we're going to have 2, and then like we knew from before, since these denominators are the same, we know that the base is going to be 6. 1 base is 6. So 2 times 3 is 6, so 3 times 3 is 9. 3 times 2 is 6, so 2 times 2 is 4. So this is our problem. And now we can subtract because we have the same denominator. 2 minus 1 is 1. 9 minus 4 is 5. 6. So you see we perfectly landed in the range of a perfect mixed fraction without any improper nonsense. Okay, let's try the next one. 3 1/2 minus 2 minus 2 2/3. So our first step is to see that, okay, we also can't just subtract the fractions. So we're going to have to borrow again. What you can see here is that, yes, okay, so we should be able to borrow. So let's cross this out, or actually, cross this out, becomes 2. This becomes a 3. So now we have 2 and 3/2 minus 2 and 2/3. Now let's turn this in, let's change the denominator. We have the same fractions as the last one, so we know that 6 is going to be the base. And now we can do the numerator. So 2 times 3 is 6, 3 times 3 is 9, 3 times 2 is 6, 2 times 2 is 4. Now we subtract. 2 minus 2 is 0, so we don't have a whole number anymore. 9 minus 4 is 5. Our answer is 5/6. Now let's look at the next problem. 4 and 3/4 minus 2 and 7/8. So 7/8 is bigger than 3/4. So we're going to have to do some borrowing. Let's do that first. So cross out the 4, it becomes a 3. 1, like the number 1 in fraction form, is 4/4. So we're going to add 4 to the numerator. So now it's 7/4. So now we have this fraction. The thing is, now we realize that we have different denominators, but good thing is that we only have to convert the first one because we can change 4 into 8, because 8 is a multiple of 4. So let's do that. 3 we carry over, and now this is going to have a base of 8. And so 4 times 2 is 8, so 7 times 2 is 14. Now let's subtract. 3 minus 2 is 1. 14 minus 7 is 7/8. And we have a perfect fraction answer. Now we have one more problem. 3 and 3/4 minus 1 and 4/5. So 4/5 is greater than 3/4, so we're going to have to borrow again. Let's cross out and make that a 2, and then add 4 to the numerator, so it's 7. And so we have two different denominators. We're going to have to calculate the least common multiple for these. So let's do that. 4, 8, 12, 16, 20, and then 5, 10, 15, 20. 20 is the first one they have in common, so we're going to use 20. Let's convert. 4 times 5 is equal to 20, and 5 times 7 is equal to 35. 5 times 4 is equal to 20, 4 times 4 is equal to 16. And now we can subtract, so 2 minus 1 is equal to 1, 35 minus 16 is equal to 19. So our answer is 1 and 19/20. That's the end of this practice for subtracting fractions with different denominators. Thanks for listening, and see you next time.